Sport climbing is a style of rock climbing that relies on permanent protection such as bolts being fixed to the rock. Due to the relatively safe environment, this allows climbers to focus upon more athletic and gymnastic movements with a significantly reduced risk. Sport climbing became popular in the 1980s, and the emphasis that it placed upon strength, power, and stamina led to large improvements in standards of climbing. Anthropometry. A summary of anthropometric data can be found in table. Body composition. A study determined that, on average, elite climbers had a lower percentage body fat compared with recreational climbers. Still, it was concluded that there was little evidence to support that low percentage body fat contributed to successful climbing. It is interesting to note that the differing conclusions regarding percentage body fat may be due to the following: varying subject ability, method of assessment, method used to calculate body composition. On average, World Cup finalists, and thus climbers of a higher standard, had a lower body mass than semi-finalists. In contrast, another study found that body mass between elite and recreational climbers was similar. This conflicting evidence may be due to the differing ability of participants, and makes it difficult to determine the role of body mass in climbing performance. Body dimensions. Body dimensions such as height and ape index may affect climbing ability. A study found climbers to be on average 1.8 meters in height, which is comparable with climbers in other studies. Ape index is a comparison of arm span to height. A positive ape index can be established when the subject has a greater arm span than height. On average, elite climbers possessed a plus 2.5 centimeters ape index, which did not differ from the general population. With this in mind, it could be suggested that both height and ape index are not a prerequisite for climbing success, but as reach is perceived as advantageous in climbing, a positive ape index may be beneficial. Muscular strength and endurance. Muscular strength and endurance in rock climbers have been primarily measured on the forearm, hand, and fingers via dynamometry. A summary of forearm and hand strength data can be found in the tables, with a summary of finger strength in this table. For the purposes of this article, hand grip strength is considered that which involves a gripping motion and is predominantly measured using a dynamometer. Finger strength involves the use of a climbing-specific finger position, and forearm hand grip endurance is measured during sustained and repetitive isometric contractions at a percentage of maximum voluntary contraction. Hand-related strength. Hand-related strength and endurance has been measured using a hand grip dynamometer. It is questionable how applicable this can be to climbing-related strength because of its lack of specificity. Of the four grips commonly used in climbing, X figure 2, only the pinch is similar to that of the dynamometer. This may explain why little correlation between absolute hand grip strength and climbing ability was found. Maximum grip strength has been measured on both hands and the perceived dominant hand. Measuring maximum grip strength on the perceived dominant hand may increase the variability through the data, as measurements may be taken on the subject's weaker hand. Furthermore, climbing involves the use of both hands. To measure only the dominant hand questions the specificity of the research and also reduces the validity of the study. However, in contrast, grip strength values for elite and non-climbers have also been shown to be comparable. Reported values for absolute hand grip strength were not considerably higher when compared with the normal population. When expressed relative to body mass, strength to body mass ratio was significantly higher in elite climbers. Forearm hand grip endurance. Rock climbing involves intermittent isometric forearm muscular contractions. While climbing, it is essential to be able to use a variety of grips, X figure 2. This could suggest that the most accurate measure of hand grip endurance would be one that measures the ability to perform repeated isometric contractions using an assortment of grips. When measuring hand grip endurance, investigators should be cautious comparing the results of exercises using different grip styles, as the degree of stress each grip places upon the forearm is unknown. Finger strength. It could be suggested that the type of finger strength predominantly used while gripping a hold during climbing is isometric strength. This occurs when muscles and tendons hold their opposing muscles and levers in a locked position. Force expressed by the climber is equal to the negative force under gravity. It has been suggested that the main distinguishing feature between elite and recreational climbers was finger strength, with climbers being able to generate a significantly greater fingertip force than sedentary subjects. Apparatus developed by the Department of Mechanical Engineering at Glasgow University allowed finger strength to be measured in two different positions in isolation. Such conditions did not take into account finger strength in relation to climbing, as it was measured irrespective of body weight. With this in mind, one must question the face validity and specificity of the measurement. However, to measure to the maximum strength of the fingers and any muscle group, this must be done in isolation. Shoulder girdle strength and endurance. Upper body strength has been identified as a potential determinant of successful climbing. Each study used a climbing-specific fingerboard to measure shoulder girdle strength and endurance via pull-ups and bent arm hang. A pull-up used the jug holds on the climbing-specific fingerboard and consisted of hanging from full arm extension and pulling the body up until the chin had reached a marked point on the fingerboard. A bent arm hang also used the jug holds on the climbing-specific fingerboard. The subjects adopted a position so the chin was just above the bottom of the fingerboard and the elbow joint was at 90 degrees, with the subject maintaining the position for as long as possible. Flexibility. Flexibility is a measure of the range of motion available at a joint or a group of joints. It is determined by the shape of the bones, cartilage, the joint, and by the length and extensibility of muscles, tendons, ligaments and fascia that cross that joint. It is frequently suggested that flexibility is an important component for climbing fitness. Certain moves such as bridging and high stepping lead to the suggestion that increasing climbing-related flexibility may be beneficial. A study found that elite climbers had a noticeably higher leg span when compared with recreational climbers. Conversely, another study found no significant difference between elite, recreational, and non-climbers. Such results should be interpreted with caution because of the classification of elite climbers. Physiological and metabolic responses to climbing. Many researchers have encountered difficulties when attempting to assess and analyze the physiological responses to rock climbing. The development of portable instruments has allowed more sport-specific data collection to take place. Oxygen uptake and energy expenditure. A summary of oxygen uptake, VO2, during climbing, running, cycling and other protocols can be found in the tables. Climbing VO2 has been measured during indoor climbing, both leading and top roping, and on climbing-specific treadmills. Blood pressure. Blood pressure has not been directly measured during climbing. A study measured arterial blood pressure responses to sustained and rhythmic exercise and arterial occlusion in trained climbers and non-climbers. They found that trained climbers had an attenuated blood pressure response to isometric hand grip exercises when compared with non-climbers. This could be explained by desensitization of the afferent nerves or a reduced metabolite buildup causing less stimulation of the muscle metaboflex. It was also noted that climbers had an enhanced vasodilator capacity. Blood lactate. A summary of studies that measured blood lactate levels post-climbing is shown in table. Blood lactate has been shown to increase when climbing angles became greater than vertical. Although blood lactate changes in subjects in some studies were small, this still represents significant muscle metabolic events due to the small amount of muscle activity during climbing. This could be explained by the fact that much of the mass supported during steep rock climbing is likely provided by the forearm muscles. Such studies suggest that a significant amount of blood lactate is produced during climbing and increases during climbing difficulty. From this, it could be concluded that an increased ability to tolerate and remove lactic acid during climbing would be beneficial. Heart rate. Heart rate and the difficulty of climbing increase in a linear fashion. In summary from the previous studies, it would appear that heart rate rises as climbing difficulty increases and falls with increased climbing experience. This can be attributed to a number of factors. When attempting to assess heart rate during climbing, psychological influences should be kept to a minimum by allowing the subject to be familiar with climbing routes.